Okay, I'm back. So this is called VEX robotics parts, and this is what, if you were in class, you would be putting together. And that's the fun part. I know you're missing out on the fun part. It kind of stinks, but we're going to see how much I can get you to understand at least gears and gear ratios and mechanisms, how they work. So you have in your packet there on the second page, like I showed you in the last video, a bunch of pictures of different mechanisms. And what would happen in class, we'd put those together and then you answer those questions and you use this packet on a test. Well, we're not going to take any tests, but what I'm going to have you do is write your answers in the packet, take pictures of it, and turn it in so I can give you credit for doing that. And hopefully learn something along the way. So I always go through in class with kids that first set of questions on simple gear train. So no, these are two separate, these are both a simple gear train. A simple gear train is any set of gears or any gear train where there's just two sets of gears, basically an input and an output. So they're both a simple gear train, but in your packet, they call one simple gear train A, one simple gear train B, just to designate that they are different from each other. And we'll get to that in a second. So let's answer the questions. The first 11 in your packet there are on simple gear train. Some of them ask about A, some ask about B, some ask about both. So like question number 1 says, what is the relationship of the input shaft compared to the output shaft? So this could be for either one of those. And here's what they're talking about. You've got an input shaft here. Or no, you've got an input shaft here, sorry. Your output shaft is here. Over here, input shaft, output shaft. How do they lay in comparison to each other? They're parallel, right? So question number 1, write parallel. Number 2 says label the drive and driven gears or input and output. Remember I said Project Lead the Way likes to call them drive and driven. I kind of like input and output better. It's up to you. But what they want you to do is just on your picture on your paper, label them. And you know the input is which one? The input's going to be the one with the crank, right? So we get these babies spinning. I haven't shown you that yet. Okay. The one with the crank's going to be the input. Obviously, the other one is the output. So just label that on your drawing, on your picture. 3 says gear train A is the speed in gear train A is the speed increased, decreased, or constant. So here's simple gear train A. Is the speed increased, decreased, or constant? Well, what did I say if you have two gears spinning and they're both the same size? We're not changing speed or torque, right? So those are constant. You can just circle constant on there. Number 4, in gear train B, is the speed increased, decreased, or constant? So think about this now. When I spin simple gear train B, which of these is going faster? And I know it might be hard to see on the video. The lighting's not the greatest and everything. But just think about it. The big one's got farther to go around, right? The little one's got a smaller distance to move. Therefore, it's going to spin faster, right? So this output shaft is spinning faster than that input shaft. Therefore, we are increasing speed. So number 4, speed would increase. Number 5, they're going back to gear train A, asking about torque. Is torque increased, decreased, or constant? Well, obviously, torque is constant because speed was constant, right? If you got two gears the same size, speed and torque are both constant. Then number 6 says, in gear train B, is torque increased, decreased, or constant? Well, I told you that speed was increased, therefore torque would be what? And hopefully you're sitting there saying, if speed's increased, torque is decreased. So hopefully you know that. I can't quiz you in school here and say, but hopefully you know that if speed goes up, torque goes down. So torque is decreased in this one. Number 7 says the gear ratio in A, or what is the gear ratio in gear train A? What do you suppose the gear ratio is here? It's 1 to 1, right? Because they are the same size. So we talked about figuring out gear ratios. Guess what? It's time to do that now because B says, what is the gear, or number 8, sorry, says, what is the gear ratio in gear train B? And I'm going to go to my whiteboard to show you that because I want to draw it out for you. So hopefully you can see this. I know the lighting isn't the greatest. Yeah, that's not too bad. So let's talk about our gear ratio rules. What was rule number 1 that we wrote on the observing mechanisms packet? We wrote output comes first, right? So we go output, input. Now, you don't have these gears in your hand, but what I make kids do in class is actually count the teeth on the gears. And there are, well, let me get it. Which one's bigger? The input's the bigger one, right? Okay, so the input, when kids count that, they come up with 60 teeth on the input. And there are 36 teeth on the output. So you could say that our gear ratio is 36 to 60. But can we reduce that? For sure. Now it's nice to get gear ratios down to where one of the numbers is a 1, but it's not absolutely necessary. So I'm going to give you 2 right answers here. Okay. So what number goes into both of these equally? Well, 6, right? So 6 times 6 is 36. 6 times 10 is 60. So now you say, well, you can do this again, right? What number goes into both of them? 2. So we take them in half, and we have 2 goes into 6 3 times, 2 goes into 10 5 times. We have a ratio of 3 to 5. That is one correct answer. There is another one where you can get it down to where one of them is a 1. Because then it's kind of nice because you say, okay, I know this one rotates once and this one goes this far. So the way to do that, we would actually back up here. Rather than go from 3 to 5, look at 6 to 10. What can we do there? We got a decimal here and a decimal here. How can we make one of these a 1? Move the decimal over, right? Move the decimal to there. Move the decimal to there. What is that gear ratio? That gear ratio would be 0.6 to 1. So now we think about, we ask ourselves, does this make sense? We said that we're increasing speed. What did rule number 2 say? Rule number 2 says, if the first number is bigger, we increase torque. First number smaller, right? Therefore, we're increasing speed. Therefore, we put them in the right order. So now let's look at this. One of these gears will turn, this was like the explanation we did on the observing mechanisms. One of these gears will turn 5 times, while the other one turns 3 times. So let's look. It's a little bit tough to see, but hopefully I can get the lighting good enough you can see it. So watch what happens here. I'm going to put a mark with my dry erase marker. I don't know if you guys will be able to see it on the video or not. I'm going to put a mark on the top tooth on both gears. And we're going to count. Usually I have one kid count one gear, another kid count the other gear. Oh, you actually can see that on the video. Good. So I'm going to have to count both of them. We're going to see how many times they go. So watch. There is 1 on the output. Now we've got 1 on the input, 2 on the output, 3 on the output, 2 on the input, 4 on the output, 3 on the input, 5 on the output, and they're back up to the top and they met. So just like we said, 3 to 5. So when we look at our gear ratio that I wrote down back there on the board, it says 3 to 5. It says the output is 3. So you go, whoa, wait a minute. The output, okay, the output spun more times. Yes, it did, but it's a smaller one. Therefore, it gets a smaller number. Okay, so here's the other thing I want to show you. It goes 3 and 5. Watch what happens if I turn this once. Or no, if I make the output go 1 time, watch. Output just went 1 time. How much did the input go? A little over a half, right? Or 0.6. There's our 0.6 to 1. So we covered both answers that I told you were right for the gear train, for the gear ratio. Okay, so back to having these next to each other. That was number 8. So you could have either 3 to 5 or 0.6 to 1. Number 9 says is a full power reversible. That says, can you make the input shaft turn by spinning? Can you make the input shaft turn by spinning the output shaft? So look what happens when I spin the output or I spin the gear. The input shaft spins, right? Same with this one. I spin the output, the input spins. The only thing that's different is which one I put the crank on, right? So if I put the crank on over here, what's this one going to do? It's going to increase torque rather than speed, right? So number 9 is yes, the flow of power is reversible. Some of the mechanisms you're going to see, it won't be. Then number 10, do gears move in the same or opposite direction? Well, let's spin that. Are they spinning in the same or opposite? Hopefully you're saying they are opposite. Okay. And then number 11 says, where is a simple gear train used? Instead of, or where might it be used? Instead of using that website that your sheet gives you, that one doesn't really work very well anymore. Just do a Google search where you type in, where is a simple gear train used, and see what you get. Because it's good to know what things these are used on. Or go back to the front page of your packet. That kind of told you where some gear trains are used too. But different ones are used in different things. So anyways, that covers the first of our mechanisms or our gears. Now you're going to go on and fill out the rest of the packet by videos that I will be posting the next couple days. We're not going to do this all in one day. So that's what's coming up next is more videos so you can answer the questions as you go through the packet. All right, good luck. So that's actually all you have to do today.